Hello everyone, welcome to Homework 14. This is the second part of your exponent review. Alright, it says right here, our work with exponential expressions so far have been limited to exponents. Apparently I cut that off a little bit when I copy and pasted, but are limited to exponents that are positive integers or zero. Here we're going to expand the given meaning of an expression like that should have been x to either the -2 or the -3. I'm going to assume -3. Okay. So, suppose that we wish to simplify the expression x squared over x to the fifth. If we use the quotient rule for the exponents, we subtract the exponents. So you always subtract the top from the bottom. So they're doing 2 minus 5 to get x to the -3. Okay. So what does that actually mean? So if you simplify it using the definition, x squared means you have two x's, so x times x. X to the fifth means you have 5. So x times x times x times x times x. When you divide, you take 1 off the top, 1 off the bottom, and what are we left with? 3 on the bottom. So by using our quotient rule definition and our just what exponents mean definition, we know that x cubed is equivalent to x to the -3. And if you put those in your calculator, you can also kind of play around with this and find out. If you have, so if I put numbers instead, if we do 2 to the -3, you're going to get in your calculator 1/8. Which is the same as 1 over 2 to the -3. And so by this definition, if we have a negative exponent, all you have to do to change that positive is to put it into the numerator. So y to the -4th, and I actually really like this in other words saying. Another way to write a to the -n is to take its reciprocal, which means flip it, and change the sign of its exponent. So y to the -4th becomes 1 over y to the +4. 3 to the -2 is the same as 1 over 3 squared, which is the same as 1/9. -2 to the 4th is the same as 1 over -2 to the 4th, which equals 1 over 16. -2x to the -1. So be careful with that one. Remember last lesson, if you don't have parentheses, that exponent only goes to what's in front of it. So that -2 is going to stay where it is. And then that x to the first, or just x, goes down to the bottom. Now, if that was -2 in parentheses to the -1st, then we could take that -2 down to the bottom with it. Parentheses make a world of a difference, especially with exponents. And then here, 1 or 2 to the -1 becomes becomes 1/2. 4 to the -1 becomes 1/4, and 1/2 plus 1/4 is 3/4. Okay, so just like when we had rationalizing denominator, the whole point of that was because something like x square root 5 is improper, right? that was equivalent to x square root 5 over 5. That's the same thing that we're doing here. We're saying this is improper, and I don't know why in math we don't like these negative exponents. Here, this was a division problem thing. So if I change that actually to 4 over square root 5, to get that equivalent decimal, you'd have to do square root 5 divided by 4. And it's hard to divide in a square root 5. So when they would change that to 4 square root 5 over 5, it's easier to divide in a number we're familiar with. That's a side note, sorry. I don't know why this is considered improper with negative exponents, but more times than not, we want positive exponents rather than negative. Now, in calculus, you're going to be going a lot the opposite way. You're going to be given something like 1 over y to the 4th. And that's hard to take, not hard, but it's more steps to take the derivative of this right here, because you'd have to use the quotient rule. So instead, you're going to change it to y to the negative 4, and now that just becomes a power rule. So in calculus, you're going to often start in this way and bring it to this way here. Okay, so that's the majority of the reason we're doing this exponent review. So just like taking it from the top negative and putting it in the bottom makes it positive, if you have a negative exponent in the bottom, to get it positive, it goes up to the top. So you're just flipping it to make it go where you need it to go to become positive. So x to the negative 3rd goes up to the top, so that's just x to the 3rd. 1 over 3 to the negative 4 becomes just positive 3 over 4, and 3 to the 4th is 81. Now on C and D, we're using both of these rules and we're going to use it at the same time. P is negative, so it's going to go down to the bottom. And Q is negative, so it's going to go up to the top. Sorry, I keep boxing it and then going over it. Okay. Same thing here. Negative on top goes to the bottom. Negative on bottom goes to the top. So this is going to become t to the 5th over t cubed. Now, this one, I can simplify more. Remember, if I said if you have the same variable wrote twice, that's not fully simplified. We were simplified on C because you had a base of Q and a base of P. But here when I have the same bases, we're going to subtract. And so 5 minus 3 becomes t squared. Now example 3 is really the exact same thing. But what we are doing with, well, the point of exercise 3 is to make sure you are aware that you're only moving what's negative. So, for example, on A, my x has a positive exponent, right? That's to the 1st power. So I'm not going to move it to the bottom and change it negative. That defeats the purpose of writing our answers with positive exponents. What I am going to do is move that x up to the, or that y up to the top. So I've got x y squared. So don't move everything. You're only moving what's negative to change it to positive. Same thing on B. I don't care about negative coefficients. So that 3 is staying on the top. But that x to the negative 4 needs to come up to the top. So I've got negative 3x to the 4th. Okay, again, we can have negative numbers, just not negative exponents. On C, we're moving the A down to the bottom since it's negative. But my B is good. It's already positive. So this becomes 1 over A to the 7th, B to the 5th. Okay, so what am I moving on D? Am I moving R, S, or T? All of them, none of them, one of them, two of them. What are we moving? We're moving R and we're moving T, but S is going to stay because S is positive. So I've got S to the 4th, T squared, all over R to the 6th. And again, those all have different bases, so that's simplified. So now that we have gone over our negative exponents and we know how to change them positive, we're going to add that onto every rule that was in that first lesson. So we've got the product rule. When the bases are the same and we're multiplying, we add the exponents. A power to a power, we multiply. Power of a product, distribute that exponent to everything. Power to a quotient, distribute that exponent to everything at top and everything in bottom. Quotient rule, when my bases are the same, we're going to subtract those exponents. Anything to the first power, anything to the 0 power is 1. And then our newest one of negative exponents. So simplify each expression, write the results using positive exponents only. So I'm going to show you 2 ways to solve a problem like this. I'll show you one way on this one and one way on this one since they're very similar. On A, if I use that power rule first, distribute it to everything in top and bottom. So I've got 2 to the negative 3 over 3 to the negative 3. Before I evaluate, I'm going to get positive exponents. So my 3 needs to go up and my 2 needs to go down since those exponents are negative. So now I've got 3 cubed over 2 cubed. And now I can evaluate. 3 cubed is 27 over 2 cubed is 8. Now the other way you can handle that is if you notice when I had this as a negative, the 2 went down and the 3 went up. So what you also could do is because this is negative here, we can change this and flip that fraction to 5 over 1, and then that's all to the 4th power. Now that I've flipped everything, I can change this exponent to positive. So that becomes 5 to the 4th over 1 to the 4th. 5 to the 4th, I think is 325 or 625. Okay. 625. And then 1 to the 4th is 1. Okay, so you can do that either way there. On C, what I like to do first is to change all of those exponents positive. So this negative 1 needs to go up, but remember this P right here already has a positive exponent, so we're not moving it. You're not moving everything, just what's positive or what's negative. So that's going to be P times P to the 1st when I take this and move it up. And now use your product rule. Your product rule says when you have the same bases, add the exponents. So 1 plus 1 gives me P squared. Okay, same thing on D, but opposite. Now the top is negative, so it's going to go down, but this K is already positive, so leave it where it is. So this is going to become 1 over K times K to the 1st, right, when that gets moved down. Add your exponents, 1 plus 1 gives me 1 over K squared. On E, I'm going to move what is negative, and the only thing that's negative is that m to the negative 2 on the bottom. So I've got m squared, or sorry, m to the 7th, m, and then now m squared. So add all of your exponents. Remember there's a 1 right there, so 7 plus 1 plus 2 gives me m to the 10th. Same thing here, move that negative up to the top. So I've got a to the 10th, and then when I move this one up, we get a to the 1st. Add your exponents. There's a 1 here as well. So 1 plus 10 plus 1 gives me a to the 12th. Okay, G and H actually have nothing to do with negative exponents. Here, deal with your coefficients the way we always do. So negative 10 divided by negative 5 gives me a positive 2. And then here we have the same base. So when you have the same base, use your quotient rule and subtract your exponents. So n to the 12th over n cubed becomes n to the 9th. 12 minus 3. Same thing here. Negative 20 divided by 4 gives me negative 5. And then use your quotient rule. J to the 8th over j squared. Subtract your exponents to get j to the 6th. Okay, so those have nothing to do with negative exponents. On I, use your power of a product rule and distribute that negative to everything, or that exponent to everything. So I got y to the 18th, negative 3 times negative 6, and then z, 6 times negative 6 to get negative 36. We have not wrote that with positive exponents, so my final answer is going to be y to the 18th over z to the 36th. Okay, and again, I'm not subtracting those because those have different bases. On j, we can do it either this way or this way. It does not matter which. I'm going to use the first way though. So I'm going to use my power of a product rule and multiply that to everything, including what? Including the coefficient. So this becomes 3 to the negative 4, b to the negative 8, all over c to the negative 4. Now here, everything is negative, so I'm moving everything. What's on top goes to the bottom, and what's on bottom goes to the top. And when you move it, change them from negative to positive. The whole point of moving them from numerator to denominator or otherwise is to make those exponents from negative to positive. And then the only other thing I can do is simplify my 3 to the 4th. So my final answer is c to the 4th over 81 b to the 8th. Okay, on K, what I think is easiest is just to make sure you have all positive exponents. So I need to move this 4 to the negative 1, my w to the negative 3, and my 4 to the negative 3 all need to move. These other ones, though, are good where they are. So this becomes 4 cubed. Let me move this over a little bit. This becomes 4 cubed. U to the 6th, right? Moving this. Oh, I didn't circle that one earlier, did I? I'm so sorry. Moving this up and moving this up and keeping this where it is. And then on the bottom, I'm going to have 4 to the 1st, w squared, and w cubed. So I moved this and this to the bottom, and I kept this w squared where it is. So now I am going to These have the same bases. I'm going to subtract their exponents, use the quotient rule. So I have 4 squared. Here we're using the product rule. So 1 plus 6 gives me u to the 7th. All over, add these up, product rule. So 2 plus 3 gives me w to the 5th. And the only other thing I can do here is simplify 4 squared to get 16. So my final answer is 16 u to the 7th, w to the 5th. Now, notice here I use the quotient rule. If you wanted to, you could evaluate that and you would get, oops. Here you would get 64 over right here, 4, and 64 divided by 4 would still give you 16. So you can evaluate and then simplify if you don't want to use the quotient rule. And then lastly, we've got all of this to the 3rd power. So let's use power of a product and distribute that 3 to everything in here, including what? Hopefully said including coefficients. So this is -2, and I'm going to put that in parentheses, cubed. It doesn't matter here since my exponent is odd, but if that's an even exponent, those parentheses are going to make a difference. So -2 in parentheses cubed. Then I'm going to have d to the 9th, 3 times 3, f cubed, 1 times 3, all over d cubed, 1 times 3, and f to the -3, -1 times 3. So the only thing I need to move is this f. And I'm going to go ahead and evaluate this. So this becomes -8, d to the 9th, f cubed, and then this one goes up. So another f cubed, all over d cubed. And so now my final answer is 8 d to the 6th. Use your quotient rule here. We're not dividing. It's 9 minus 3. And then use your product rule here. 3 plus 3 gives me f to the 6th. Okay, so that's all I have for this lesson. It can be very overwhelming if you did not practice and master your exponent rules from the lesson before, right? Because we only added 1 to this lesson, but from here, you needed to know these 1, 2, 3, 4, 5, 6 different rules, and then we added this one. If you have any questions, please feel free to contact me. Otherwise, I will see you next lesson.